Welcome to the DIY Honda Garage channel. The diagnostic trouble codes, DTCs, P0301, P0302, P0303, and P0304 indicate that there are misfires occurring in the Honda Civic 2006 to 2011 models. Specifically, P0301 refers to a misfire in the first cylinder, P0302 in the second cylinder, P0303 in the third, and P0304 in the fourth. A misfire means that the cylinder is not firing as intended, resulting in improper engine performance and increased emissions. It's critical to address these misfires, as they can lead to further engine complications if left unresolved. The causes of these misfires can range from ignition system failures to fuel delivery issues, and a systematic troubleshooting approach must be applied to accurately diagnose the root cause. Misfires occur in the engine's cylinders, where fuel and air should ignite to provide power. Each cylinder is equipped with a spark plug, ignition coil, fuel injector, and is checked by the Engine Control Module, ECM, for proper operation. The ignition coil generates the high voltage needed to produce a spark at the spark plug. Misfires can also stem from issues in fuel delivery, as each fuel injector delivers fuel to the corresponding cylinder. For the Honda Civic, the ECM will monitor cylinder performance. Location-wise, cylinders are numbered from 1 to 4, starting from the timing belt side of the engine block. Ensuring these components function properly is crucial for achieving smooth engine operation and avoiding further issues. The primary causes for these misfire codes can be categorized into three main areas. Firstly, faulty ignition components may include worn spark plugs or malfunctioning ignition coils that fail to create a sufficient spark for combustion. Secondly, fuel delivery issues, such as clogged fuel injectors, can prevent the correct air-fuel mixture from entering the cylinders, leading to misfires. Lastly, mechanical problems, including low compression in the cylinders or valve timing issues, can also contribute to misfires. Each of these causes needs careful inspection during the troubleshooting process to restore normal engine function. Understanding these potential causes sets the groundwork for effective diagnostics and repairs. Symptoms of cylinder misfires can manifest in various noticeable ways. One of the most common symptoms is a rough engine idle, which may lead to a shaking feeling while the vehicle is stationary. This roughness arises from uneven power delivery due to misfiring. Additionally, drivers may experience poor acceleration when attempting to accelerate, further indicating that the engine is not responding efficiently. Another clear indicator is the illumination of the check engine light on the dashboard, signaling that the engine management system has detected an issue needing attention. Recognizing these symptoms is vital for timely intervention to prevent potential damage to the engine or associated components. In the first step of troubleshooting, you need to turn the ignition switch to the on position, specifically position 2. This activates the vehicle's electrical systems without starting the engine. Once in this position, the Honda Diagnostic System, HDS, should be used to clear the current DTCs stored in the system. This step is crucial as it allows you to reset any previous codes that may no longer be relevant. After clearing, the next action is to start the engine and allow it to idle without any load. Idling in neutral or park enables you to observe the engine performance without any additional stress. Monitoring in this state sets a baseline for further diagnostics. After idling the engine, the next step involves using the HDS to monitor the onboard diagnostics (OBD) status for any of the misfire DTCs. The HDS provides real-time data and can help determine whether the misfire issue has persisted. If the status shows failed, this indicates that one of the cylinders continues to misfire, signaling a need for further investigation. Conversely, if the status shows passed, it suggests that the misfire issue may have resolved temporarily, and further checks may be required depending on if it shows executing or out of condition. Should the screen indicate any of these conditions, follow the prescribed next steps accordingly to continue the troubleshooting process effectively. In the third troubleshooting step, check the cylinder misfire counts for all 4 cylinders, specifically for 10 minutes in the data list provided by the HDS. This close monitoring allows you to detect any immediate misfire events that may not have been flagged as persistent codes yet. A count indicates how many times each cylinder has failed to ignite properly during this period. If any cylinder shows misfire counts, it reinforces the need to further diagnose the problem. If no counts are recorded, this suggests the system may be operating correctly at this time, but intermittent issues could still be present. Hence, the condition requires careful observation and further testing. The fourth step involves a test drive of the vehicle to gather more data under actual driving conditions. This step should be executed in line with previously recorded freeze data parameters, such as engine speed and vehicle speed sensor readings. During the test drive, it's essential to observe these parameters closely, as they offer insight into how the engine behaves under load and can potentially trigger misfire conditions that wouldn't arise in idle. Monitoring these specific parameters allows for deep diagnostics, and any deviations should be noted. If the status afterward shows failed, it indicates ongoing issues that require immediate attention. Upon completing the test drive, return to monitoring the OBD status using the HDS. As before, determine if the status indicates failed, which would confirm that misfire conditions continue to exist. Should it display passed, it suggests that the engine has resolved the previous misfires, which is favorable. However, if it renders executing or out of condition, further troubleshooting must be conducted to evaluate persistent issues. Each of these outcomes informs the technician on how to best proceed with care and attention to detail to ensure complete diagnostics. The sixth step requires revisiting the check on cylinder misfires for each cylinder for another 10 minutes using the data list. This repeated monitoring provides valuable insights into whether any cylinder has started to show misfire counts after the earlier analysis. It's crucial to note if counts appear during this monitoring phase, as it suggests underlying issues that need resolution. If counts are detected, proceed to the next step of troubleshooting based on these findings. Alternatively, if there are still no counts but misfire conditions persist, it may indicate a more intermittent issue requiring further inspection of connections and terminals in both the fuel and ignition systems. In this troubleshooting step, begin by turning the ignition switch to the lock position, ensuring that all electrical systems are off. After doing so, swap the ignition coil from the cylinder exhibiting the suspected misfire with one from a functioning cylinder. This coil swap is a practical step to determine if the misfire is due to a faulty ignition coil. If the misfire moves to the new cylinder, this confirms the issue resides with the ignition coil itself. The next step is to test drive the vehicle once again, using the same freeze data parameters as before for consistency. Following this will help assess whether the issue persists in the new cylinder. Upon completing repairs or component replacements, it's crucial to verify all repairs by checking for misfire counts again using the HDS. This ensures that the new components or solutions implemented have effectively resolved the issue. Additionally, ensure there are no remaining DTCs recorded in the system. confirming that the engine management system reflects accurate operational status. A thorough final system check is necessary to validate if all functions are optimized, and the vehicle operates smoothly without further misfire occurrences. This step serves as both a validation of fixes and a preventive measure against future troubles. To prevent issues such as cylinder misfires, regular preventive maintenance is essential. First, consistently check and replace spark plugs at intervals recommended by the manufacturer. Worn spark plugs can directly lead to misfires due to insufficient spark. Secondly, regular cleaning of the fuel system is important, as clogged fuel injectors can also contribute to misfire conditions. Finally, periodic engine diagnostics can catch early signs of trouble before they escalate into larger issues. This proactive approach ensures engine longevity and optimal performance, thereby enhancing the overall driving experience. In conclusion, addressing DTCs P0301, P0302, P0303, and P0304 involves a systematic approach to troubleshooting misfires in the Honda Civic from 2006 to 2011. It is imperative to start with accurate diagnostic steps, ensuring to monitor engine conditions and evaluate potential component failures. Understanding the underlying causes enables effective rectification, while thorough testing validates the efficacy of repairs. Further, preventive maintenance plays a vital role in avoiding future issues, underscoring the importance of routine checks on ignition and fuel systems. By staying vigilant, drivers can maintain their engine's health and performance, ultimately providing a better driving experience. Please like and subscribe to the channel. See you next time.